Let's find these 5 indefinite integrals. The first one is integral cosine x minus sine x plus 4dx. What is the integral of cosine? The integral of cosine, if you do not remember the formula, you should watch the previous video. So the integral of cosine is equals to sine of x, and then this minus carry over, right? And then the integral of sine is equals to negative cosine. The integral of 4 is equals to 4x. And then don't forget, for indefinite integral, you always need to add a constant c at the end. Okay, what is that equal to? So we have a sine of x plus cosine of x, and then plus 4x plus c. This is our final answer. And how do I know this final answer is right? Simple. All you have to do is you take the derivative of that and you will be able to get back to the integrand. Okay, next problem, we have an integral of sine of 5x plus cosine of negative 7x, and then plus tangent of 10x, and then dx. So the integral of sine is equals to what? The integral of sine is equals to negative cosine, right? So normally we have a negative cosine 5x, but the question that I would like to ask you is, when you take the derivative of negative cosine 5x, are you be able to get back to the sine of 5x to do it? What is the derivative of cosine? The derivative of cosine is equals to negative sine. Alright, so the two negatives got cancelled. You have a sine of 5x, but this is a cosine of 5x. Using chain rule, you need to take the derivative of 5x, then that gives you a 5. But I didn't have a 5 in the integral, in the integrand. So what do? So when we take the derivative, that produces a 5, but we do not have a 5 in the integrand. So to get rid of that extra 5, you will have to prepare a 1 over 5. Let's try the cosine. The integral of cosine is equals to sine, so you have sine of negative 7x, but when you take the derivative of that, you have a cosine negative 7x. By chain rule, that produce a negative 7. But I didn't give you a negative 7 in the integrand. So to get rid of the negative 7, you have to do a 1 over negative 7. So now when you take the derivative of this, you will be able to get back to the integrand. How about tangent? The tangent is a ln absolute value of secant, right? So you have a ln absolute value of secant 10x, and then same concept, you have to prepare 110 in front of it, and then there is a plus c. Now, is there another way to write the secant? So is there another way to write this? So for the integral of tangent, there is an absolute value of ln absolute value of secant, or you can use this. You can use negative 1 over 10 and then ln cosine of 10x. Why do we have a negative and a cosine? Because secant is equals to 1 over sine, right? You know what? I should write this out for you. So we have a ln absolute value of secant of 10x. So secant is equals to 1 over cosine. So that is equals to 1 over cosine of 10x. So you have ln 1 divided by the other. So that is equals to ln 1 minus ln absolute value of cosine 10x, and then ln 1 is equals to 0, so this is equals to 0, so you have a minus ln absolute value of cosine of 10x. So that's how we got the negative in front of the ln. Okay, this is the end of number 2. Let's move on to number 3. Number 3, we switch color, of course. So we have integral e to the negative ax plus e to the 9x minus sine of x divided by 5 dx. Alright, the integral of e to the anything is e to the anything, right? It looks like we have e to the negative ax. Now, take the derivative of this for me. What do you get? You get this multiply negative a, but I didn't have negative a in the integrand. So how do you get rid of the extra negative 1 over a? Easy. 1 divided by negative a. So now take the derivative of this, you can get back to the integrand. All right, so for the e to the 9x, so this is a 1 over 9, e to the 9x, you have to prepare a 1 9 in front of it to get rid of the 9 when you take the derivative. And then the minus is going to carry over, so this minus is going to carry over. The integral of sine is equals to negative cosine, so we have a negative cosine x divided by 5, which is 1/5 times x. But when you take the derivative of that, there is a 1/5, right? So that becomes a sine x over 5 times 1 over 5. How do you get rid of the 1 over 5? Simple. You prepare a 5 right over there. So this is the integral of sine x minus 5. And then what else? I think that's it. So all you have to do is you clean this up. So you have negative 1 over 8 e to the negative 8x plus 1 over 9 e to the 9x, and then plus 5 cosine, and then x divided by 5, and then plus c. This will just take a little bit of practice to get used to. Speaking of extra practice, so let's practice this. How about this one? How about integral cosine x divided by 2? Cosine x divided by 2 dx. Just do it. Do an extra problem. So what is that equal to? The integral of cosine is equals to sine, right? So you are going to write sine of x divided by 2 plus c. But when you take the derivative of that, the chain rule gives you a 1/2 in front of the sine. But I don't have 1/2 in the integrand. So because of that, you will have to add a 2 to it. So that's how you handle this situation. Okay, we have 2 problems left. And then the next one is integral 2 times sine of x cosine of x dx. Write down the problem first because we are going to like move down, so you won't be able to see the problem anymore. All right. Okay, this one, it looks like I can't use any formula because this is a multiplication. I cannot integrate the sine first and then the cosine second and then multiply the result. That is not going to work. So how do we take care of this? The reason I put this problem for our discussion is I want you to review the double angle formula. So this is equals to integral sine of 2x and then dx. This is a double angle formula. I want you to review your double angle formula. 2 times sine times cosine is equals to sine of 2x, double angle formula. So this one is similar to what we just did. So the integral of sine is equals to cosine. So we have a cosine of 2x. And then when you take the derivative, the chain rule gives you a 2. To get rid of the 2, I have to prepare a 1/2. And then a plus c. And this is the answer to this integral. Let's do the last one. The last one is we have integral cosine square theta minus sine square theta d theta. It looks like the formula we learned so far cannot handle this, but this is another double angle formula for cosine. So this is equals to integral cosine of 2 theta d theta. This is a double angle formula. So double angle formula. Cosine has 3 double angle formula. The first one is cosine of 2 theta equals to cosine square theta minus sine square theta. And then another one, cosine of 2 theta. Another way to write this is, do you still remember the fundamental identity? Sine square plus cosine square equals to 1. So that means cosine square is equals to 1 minus sine square. So 1 minus sine square minus sine square, that gives you 1 minus 2 sine square theta. And then the third one is you rewrite the sine square. So sine square is equals to 1 minus cosine. So you have cosine square, subtract the quantity of 1 minus cosine. That gives you 2 cosine square theta minus 1. So there are 3 double angle formulas for cosine. So this one we have a cosine of 2 theta. The integral of cosine is equals to sine. So this is a sine of 2 theta plus c. Of course, that is not the end. When you take the derivative of sine, that produces a 2 because of the chain rule. So to get rid of that 2, you have to prepare a 1/2. And this is the answer to the 5th integral. Alright, that is the end of this video. If you like the way I teach indefinite integral, give me a thumbs up, a subscribe, and I will meet you all in the next video. Signing out.